Rewriting quadratics in standard form. In example 7, the quadratic was easily solved by factoring. However, there are many quadratics that cannot be factored. We can solve these quadratics by first rewriting them in standard form. Given a quadratic function, find the x-intercepts by rewriting in standard form. Step number 1, we're going to substitute a and b into h, which is equal to negative b over 2a. And then we're going to substitute x is equal to h into the general form of the quadratic function to find k of the vertex. And then we're going to rewrite the quadratic in standard form using h and k. And then we're going to solve for when the output of the function will be 0 to find the x-intercepts. So for example 8, we're finding the x-intercepts of a parabola. Find the x-intercepts of the quadratic function f of x, which is equal to 2x squared plus 4x minus 4. Step number 1, we begin by solving for when the output will be 0. So we have 2x squared plus 4x minus 4 equals 0. Now, because the quadratic is not easily factorable, in this case, we solve for the intercepts by first rewriting the quadratic in standard form. So standard form, f of x is going to equal a times x minus h squared plus k. So the first thing we need to do is find what a represents in step 1 and what b represents in step 1. We know that a represents positive 2, so we know a is 2. We know that b represents 4. And then we're going to plug it into our formula for h. So h is equal to negative b over 2a. So it's going to be negative 4 over 2 times 2. So negative 4 divided by 2 times 2 gives us negative 1. So we know h is negative 1. And then we're going to plug in negative 1 into the function in step 1. So we have 2 times negative 1 squared plus 4 times negative 1 minus 4. Well, this becomes 2 times positive 1, which is 2, minus 4, which gives us k to be negative 6. So, what do we know from above? We know that a is equal to 2, we know that h is negative 1, and we know that k is negative 6. And now what we're going to do is we're going to plug it into the standard form. So we know a is positive 2. We know that h is negative 1, so it's minus negative 1. And we know that k is negative 6. So we get the standard form f of x, which is equal to 2 times x plus 1 squared minus 6. And now what we can do is we can solve for when the output will be 0. So we're going to replace f of x to be 0 and solve for x. So we're going to have 2 times x plus 1 squared minus 6. So we're going to add 6 to both sides. And then we're going to divide by 2 to get x plus 1 squared equals 3. And then we're going to use the square root property. So we end up getting x plus 1 is equal to plus or minus the square root of 3. Subtracting 1 to both sides, we get x, which is equal to negative 1 plus or minus the square root of 3. So the graph has the x-intercepts. Negative 1 minus the square root of 3, 0. And negative 1 plus the square root of 3, 0. And we can check our work by graphing the given function on the graph utility and observing the x-intercepts. So let's just go ahead and use our calculator to make sure that our numbers match. So if we take negative 1 and we subtract the square root of 3, then we get negative 2.732 and then 0. And if we take negative 1 and then add the square root of 3, then we're going to get 0.732 and then your 0 for the y value. Now, we could have achieved the same results using the quadratic formula, so that would have given us the same results.